right, so this we looked at in class, the sine curve. So the sine curve is, or the sine value is our dependent variable. Our angle is the independent variable. We can measure our angle in degrees or in radians. And we know that when our angle starts at 0, my sine value, so on my unit circle, that's my y coordinate, is 0. So we start with 0, 0. And then when we hit our first angle of 30 degrees, or if we call that pi over 6, then we're at a y value of a half. If I go to 45 degrees, that would be halfway here, or that's pi over 4 radians. I get a value of root 2 over 2, so that traces out to be about here. At 60 degrees, I've got root 3 over 2, which is even higher. And then at 90 degrees, I have 30, oh, that should have been 60. Sorry. All right, 45 would have been here, and then 60 degrees a little bit higher up, and now 90 degrees is at 1. So these are my points I know clearly, my 0, my half, and my 1. So we get back to 0 when I come to 180 degrees, or that is going to be pi radians. So if we're counting everyone as 30 degrees or pi over 6, and that's the same as pi over 6, so I can label this one pi over 2. So now I know 1, 2, 3, 1, 2, 3, I'm back to 0. 1, 2, 3, I would be back down at -1 because my sine graph is positive, 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 0, negative, 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 and I've got -1 at my either 270 degrees or 3 pi over 2 radians. So we continue in this pattern, -1, back to 0. So my sine graph, nice smooth curve, as much as I can. All right, so this didn't fit on very well. So when I get down here to my cosine, I'm gonna shrink it down a little bit. And instead of counting by 30 degrees, I think I'll count by 45. So that means I'm going to call this one 90 degrees, or of course pi over 2 radians. So let's think about cosine. At 0 degrees or 0 radians, my cosine value is its maximum. That's the 1. And now cosine is going to get smaller and smaller until at 90 degrees, my x value is 0. So I'm talking about the x value here as x and y coordinates of the circle. But remember, when we're graphing, x is our independent variable of degrees or radians, angle size, and y is the ratio. So the cosine ratio of 90 degrees is 0. The cosine ratio of 180 degrees is -1. So over here, my cosine value is -1, back to 0, and then back up to 1 once I've completed a full circle. If I go into my negative angles, so now I'm going this way, cosine is positive until I hit -90, where it's 0, and then -1, and back to 0. So cosine, another smooth curve, as smooth as I can manage to draw it. And again, we have a period that was so close to being smooth. All right, so there's my cosine curve, my sine curve. So both of these curves share similar features. My domain, well, I can have any angle value. So my domain is all reals. My range, though, my minimum value is -1, my maximum is 1, inclusive. Amplitude is the height from the center. We call the center the principal axis. So if we think about our center here, amplitude is the measure from the center to the maximum or the center to the minimum. We could also think of it as half the distance between the max and min. So our amplitude is 1. Our period, how long we're taking to make a full cycle, is going to be 360 degrees or 2 pi radians. So that's the general sine and cosine curve.